Welcome everybody. So today we're going to talk about the special situation of motion with constant acceleration, which I've written down over here. And I'm going to try to use what I already know about the definition of acceleration to learn something about the velocity and eventually the position as a function of time. As we have done before, I'm going to multiply both sides of this equation by dt to get an integratable expression like this. And then I'm going to go ahead and integrate both sides from some initial time to some final time. For our purposes today, I'm going to start at t equals 0 and go up to some final time, which I'm just going to call t. And then on the velocity side, I'll integrate from some potential initial velocity, which I'll call vxi, up to some final velocity, which I'll just call v of t. Now I need to do both of these integrals, and good news, they're pretty straightforward. Because ax is a constant, this is simply going to give me ax times t evaluated between t and 0 is simply going to give me axt. And then on this side, I'm going to get the velocity in the x direction, again evaluated at the endpoints, gives me v of t minus vxi. And then the last thing that I want to do with this expression is to move the vxi over to the other side of the equation so that I can get something that looks like vx of t is equal to vx initial plus the acceleration times time. And now I know something about the velocity for an object that's moving with constant acceleration. The next thing that I can do is go through this same procedure for position using an equation like drx dt is equal to vx. I'm not going to show all the details of the integration because they're exactly the same as I have here, except that I'm going to plug this expression in for the velocity. And when I integrate it, you can see that this piece is going to pick up a time, and this piece is going to go from t to t squared over 2. And I'll go ahead and write that down. So you're going to get rx of t is equal to rx initial plus vx initial times time plus 1/2 ax t squared. Now that I have this set of equations, I want to think a little bit about what they are telling me here. This is a whole set of motion quantities, right? I have acceleration. I have velocity in the initial and final states. I have position, initial and final position. I have time. And I have many of these quantities that are repeated. And what that means is I now have the ability to go in between the different quantities. Maybe I know final position and initial position, and I want to know something about the velocity. Or maybe I know something about the velocity, and I want to know something about the acceleration. This set of equations for the situation with constant acceleration now will let me go back and forth between all of those quantities.